Hello, everybody. So thank you for tuning in again to Space Apps in Melbourne. Here with us now, so it's 1 p.m. Saturday in Melbourne, and it is much later on Friday night over in California. You're in California now, right?
Yeah, I'm in California.
Yeah.
Los Angeles.
So we're incredibly thankful. Sorry?
Los Angeles.
Los Angeles. So we're incredibly thankful that John Tucker has joined us for this chat. So John Tucker is a manager at SpaceX and recent founder of NewSpace Ventures. He earned a degree in information systems engineering from the US Air Force Academy. And he led a software test team for, now let me know if I pronounce this the correct way, but C4ISR, would that be correct?
Yes, right.
That's good. At Elgin Air Force Base in Florida. So he's then later reassigned to the Los Angeles Air Force Base, which is the home of the Space and Missile Systems Center. So during his time at SMC, he worked on Delta IV rockets and I believe Atlas V as well. Is that correct?
Correct.
Yep. And I'm going to ask about it soon, but then he has an interesting story about his experience in seeing SpaceX operate for the first time and switching over to those guys over there. So thank you everybody who is paying attention, for everyone listening in the background here at SpaceX at MoonshotX Melbourne. Yeah, so let's hear a little bit about your background. Tell us your story.
Well, so I got into space, I guess you can say, by accident. I never imagined that I would be in the space industry. I never imagined I'd be working for SpaceX. Leaving high school, my goal in life was to be a military fighter pilot. But due to medical issues with my eyes and a really long, sad story of not being able to do that, that led me to systems and weapons testing at Eglin Air Force Base in Florida. From there, I realized I really didn't fit in. Being a boy who was born and raised in Southern California, I really didn't fit in the South, where the Eglin Air Force Base is in the Floridian Panhandle. And after a number of years out there, I wanted to come back home. I wanted to come and move back to Los Angeles. So I requested a transfer while I was in the Air Force to Los Angeles Air Force Base. It was approved, but I didn't know what I would be doing. And when I showed up at LA Air Force Base, I was told that, hey, you're the new Delta IV rocket structures engineer. And much to my surprise, it was trial by fire. They tossed me in the deep end of the pool. But I absolutely loved it. It was a dream come true. I studied, a lot my first couple of months on the job, learning everything about the Delta IV launch vehicles, all the configurations, how to conduct launch operations, sitting console during launches. And my very first launch that I was approved to participate in was WGS-5. And I would never forget the first time that I experienced a launch from Cape Canaveral down in Florida. Even in the control room, miles away from the launch pad, there's this incredibly intense rumble that you just feel in your chest. And I knew I really didn't want to do much else in terms of career. I knew I wanted to stay in the space industry. So that's what kind of led me to where I am today. I didn't stay in the military. I wanted to go and experience what else the space industry had to offer. And towards the end of my military career, I'm not sure how many of you are familiar with the history of SpaceX, but right around that time, they were requesting from the United States government that they be a contender for military launch contracts. You have to be approved to launch military satellites in the United States. and they kind of raised their hands saying that, hey, we'd like to do this. So I was part of the team while I was in the Air Force that initially started going over to SpaceX and helping understand, just what SpaceX was about, how do they conduct their system engineering, and all of their production disciplines and how they conduct launch operations. We were auditing them. Our job was to provide a report at the end of whether the United States government would have enough confidence in the situation if they chose SpaceX to be a provider for military launches. But that's what really got me excited about the company, was because they weren't doing things the same way that traditional aerospace companies had been doing them for, half a century. And that's why I chose to come to SpaceX after my time in the military concluded, and that's why I continue to be a really big advocate for the new space industry as a whole. I think it's really important that we continue to push the boundaries of space around the world.
Fantastic. Was it that you covered the new space, recently in the last few months started NewSpace Ventures, which is absolutely fantastic. Can you briefly explain to those listening who might not necessarily know what is NewSpace, what differentiates space, and give us a bit of what NewSpace is?
I only caught a little bit of that. You're cutting in and out.
Sorry. So just saying, when was it that you discovered this new space area of space? And could you just give a little bit of background for people listening who might not know what NewSpace is compared to old space, and what you're doing with NewSpace Ventures as well? Okay.
So how I kind of discovered NewSpace, not just interfacing with SpaceX while I was in the military, but as I started doing more research about the industry in general, just getting general knowledge about what was going on when I first was thrown into the position of Delta Force Structures engineer, I started discovering that it wasn't just SpaceX, Blue Origin, a couple of other companies, Vector Space, Planet Labs. It wasn't just the companies that are redesigning the way rockets are built or launched and redesigning the way satellites are built and launched. There was this whole other aspect to the industry. That was certainly one part of it, but I started discovering these little startups, and some not so little anymore, that were just sort of popping up all over the world. And I thought that was absolutely incredible, that technology and education and public policy has started to shift in the direction that it was possible that high school students could build their own satellite from scratch, or design their own computer program or software that leverages data from space, that's free and open source. I thought that was amazing, and I really enjoyed discovering these little gems of information, just from the internet, and sharing that with my friends and colleagues. And that's kind of where NewSpace Ventures grew out of, just an interest to discover these NewSpace Ventures from around the globe, and share that and discuss it. So what NewSpace Ventures is now, we're just about 2 months old, but NewSpace Ventures, the goal is to surface the best new space products, services, and just companies in general every day from around the world, and grow it to be a place for space enthusiasts to share and geek out about the latest space-related hardware, software, mobile applications, tech creations, projects, to be sort of the advocate for new space.
Yeah, that's fantastic. So I'm lucky enough to be subscribed to your newsletter, where I get to see every day literally every day you send out new updates of new space companies from around the world that are popping up. I think you're in a particularly interesting position as well because you get to see how the new space industry is growing, especially since, it was quite tiny just a few years ago. It seems to be exploding now, and there's so much more investment and interest in commercial space ventures now because space is so democratized. You're also in an interesting position because you've come up your education through a very military-based, traditional aerospace as well. I guess engineering culture, and then you've shifted across to SpaceX where they try to build rockets like they're designing an app for your phone. And this will become a two-part question, but I'll leave the latter part for afterwards. But, how have you seen that change over time, and what do you think the new space industry is going to look like, say, 3 to 5 years from now, compared to what it was when it was just beginning, the first couple of startups like SpaceX that really had to have that capital and a drive to try to have that initial disruption?
So just to make sure I understand the questions, it's how do I see new space as an industry growing for like the next 5 years? And you're also asking how has that changed SpaceX, or how is that working with SpaceX?
Yeah, so I guess you've moved from working from on traditional aerospace products and traditional aerospace engineering cultures and moved into SpaceX. I remember last time I spoke to you, telling me an interesting story about you were amazed the first time you stepped into SpaceX because one of the lead engineers had dreadlocks and was wearing flip-flops.
Yeah.
And it's just totally different to what you were used to. So I'm just interested to hear more on your experience with that transition from your personal perspective and what you think it will look like in the future when we have more commercial space companies.
So first being introduced to SpaceX, it was like absolute night and day. In my role, my entire military career, you dealt with military contractors, companies like Lockheed, Boeing, particularly, of course, United Launch Alliance that builds Atlas and Delta rockets, and they are very, very good at exactly what they do. But I think the real defining factor between old space and new space is the motivation behind what they're doing. Traditional aerospace companies, their motivation is to make as much money as they can for the shareholders. And a real big hallmark of new space companies is doing something for the greater good, for humanity. SpaceX, we want to get to Mars. Companies like Rocket Lab, they want to make access to space for CubeSats and small satellites as low cost as possible, so that space can just be like lower the barrier to entry for getting access to space. So like it's their motivations for wanting to generate money different, and I think just the culture in general from the generations that have grown up. Right now, it's a very millennial generation that's coming into the new space industry, and we've grown up with the internet. We've grown up with this worldwide connectivity where, I mean, I'm talking to you guys literally from the other side of the earth, and that wasn't possible just 15 years ago, not this easily. And we take a lot of those we take a lot of those mindsets and put that into the sort of companies that are growing up, and the ways that those companies are run in particular, which is why you mentioned the story I told you is one of the lead engineers at the time. It was just really laid back. He had a tank top on, dreadlocks, flip flops, and shorts, and we were walking around the production line. Granted, as a company evolves, certain things need to change, and that is no longer allowed on the SpaceX production line. You need closed-toed shoes. It's a heavy machinery environment, but it's the culture that the new space industry is providing that is it's okay to make mistakes. It's okay to learn on the fly, and it's absolutely necessary that we try and push the limits as fast as possible. So where do I see NewSpace as an industry in 5 years? I see many more entrants into the space industry. I see a lot more satellites in low Earth orbit in particular. Everyone is saying low Earth orbit's really congested, and that's not going to change anytime soon. The first couple of companies or people with inventions that figure out how to clean up low Earth orbit are probably going to make a good amount of money, I feel. But in 5 years, there's going to be not just a lot more things in space, but there's going to be a lot more applications that utilize data and information that comes from space that we just don't even realize. You talk to half the people on the street here in the United States, and they don't necessarily understand that how Google Maps works and how you can drive your car to the store that you in a new city that you just flew into and know the route. They don't necessarily connect that with the fact that, oh, we have GPS satellites that allow you to do that. And I don't think that's a bad thing. I think that's okay, because you want the interface between humans and technology to be seamless, or as seamless as possible. But there's going to be so much more connectivity and availability with space data that we don't even realize. Now, since the ISRO launch in earlier this year, they launched, I think it was 104 satellites at once. Now, for the first time in the history of the world, we're able to take a picture of literally the entire Earth every single day, and that's never been possible before. And just think what'll happen 5 years from now.
Yeah, amazing. I think it's some really good tips around some of the space apps participants all the way around the world. I had a question lined up, but it has wrong time. So if you had any tips for participants in space apps looking to potentially create a highly valuable solution within 48-hour time frame, something that would actually have real impact that they could continue after the hackathon, is there any particular areas that you think that are worth trying to target, or any suggestions that you have for trying to tackle some problems, or discover which problems that might not necessarily be really noticeable if you're not already in the space sector? So I know, for example, there's a couple of space marketing companies that are popping up at the moment, which is totally sort of out of left field.
So let's see, what kind of space application would I create with? Do you in the Space Apps Hackathon, you guys have access to like open source data that you leverage?
Yeah, for sure. This year in particular, a lot of the focus is on Earth observation and processing, so basically big data problems, processing geospatial information data sets and things like that. So we've got access to open source and some sponsorships to provide some closed source data sets for us as well. But here in Melbourne and in the Australian cities, we're also expanding some of the challenges outside of that scope to include things from essentially things that could have a commercial focus. It could be US space law, providing insurance to low-risk space activities, which for us in Australia is quite important. Just wondering if there's any tips out there for anyone looking to create a solution that currently thinks about space is mostly just, like you said, a lot of people don't realize that the interface, deep down that, I guess, supply chain is really supported by space. On your phone, you don't really connect that with satellites. So do you have any trying to research, trying to find new areas they might be able to have a big impact?
Yeah, so you mentioned Earth observation, and the way, like there seems to be an awful lot of companies trying to leverage the Earth observation data in various ways. You know, with tracking global warming, or helping helping different governments coordinate disaster relief efforts, that sort of thing. But like what I mentioned, like 5 years from now, where I see more of the connection to just the everyday person, I think applications that can leverage Earth observation data, but connect it to the growing Internet of Things. So, you know, somebody who has a farm, or somebody who is in charge of maybe a hotel, or city planners for a city, if they can use that Earth observation data, and going back to the farmer example, using that data to help learn when is the optimal time to plant their crops, or when is the optimal time to harvest those crops, or in connecting it to the Internet of Things, maybe you can use Earth's observation data to intelligently, automatically, like robotically route your tractors to dig in the right rows at the right times, or use that data to automatically turn your sprinklers on when the soil's too dry, that sort of thing.
One of the things that, so I'm an electrical engineer, so I'm used to more building hardware, physics-based things rather than software. One of the things that I find really interesting in this sort of startup and entrepreneurial community, which is really sort of latched onto apps and software devices and things like that, is lean methodologies and lean development, that sort of stuff. As we know, so engineering, so for example, if you were to build a rocket for NASA, you have to really be careful in how you design that. It has to be very meticulous. And you might actually be able to make an argument that it gets in the way of innovation. Yet here you've got SpaceX, which is, you know, building a rocket, or building rockets, I should say, you know, the ones that can land out at sea. That's really, I guess, you know, the epitome of engineering, hardware engineering. And so to apply lean manufacturing methodologies to that area is I think, really, really interesting. Because it's really a balance between getting out quick, rapid prototypes and testing stuff as much as possible. You have to be really careful, because there's a lot of money and a lot of, you know, people's lives are at risk. So how does SpaceX balance that in terms of pushing the envelope as much as they have, yet treating the development of an entire rocket system as though it's software, and, you know, reducing the cost greatly compared to what was on offer before, and just being able to achieve things where so many people have said, no, it's not possible to launch, to land a booster back down in the ocean.
Yeah, no, you're absolutely right. The crux of what SpaceX is, the crux of how SpaceX is able to do these things is because we're not thinking about the traditional aerospace version of a production line, or even an auto manufacturing production line, for that matter. Yes, Tesla is also owned by Elon Musk and that sort of thing, but I guarantee that the production lines that Tesla has is very different than the production lines SpaceX has. The way you can kind of think about it is a traditional aerospace company like United Launch Alliance. They build really, really good launch vehicles. They're robust. They're tested, but they're really expensive, because it's like every single time you're building a Ferrari, or you're building an Aston Martin, a very well-made one-off car that you use once. And the mentality that SpaceX is trying to apply, with I would say a good amount of success so far, is like the Toyota or the Honda. Like you don't need to be as complicated with the production line and with the engineering, and you want to build a lot of them, because it does the job. And so that mentality is transferred to our engineering and our production line. All of the engineering that we do is with the mentality that, you know, this isn't a one-off. We're going to need to use this again. But if we don't have the technology, or we're not sure what the technology is, how to best implement it, then we iterate on it as fast as possible. So far, SpaceX has not launched the exact same rocket twice. Yes, we did relaunch a landed booster, but with a brand new second stage. And even on the second stage, you know, we were trying out a couple different things on the engineering side with thermal protection and that sort of thing, because we're always iterating on our design to make it better and better every time. Yes, that doesn't make our production line very efficient. To really have an efficient production line, you need to have a very stable product, a repeatable, consistent process. But a repeatable, consistent process doesn't push the envelope of technology and doesn't it doesn't get us to Mars, or at least it doesn't get us to Mars fast enough. So we're okay spending more time and more money now to prove out these technologies and prove out these concepts, and, you know, in some cases say, you know what, I know you built all of that sort of part and it's in inventory, but forget about that. This is why we need to now build this new version of the part, and it's better in these ways. And also, a big reason why SpaceX is different and challenging is that most production lines have two separate ones. You know, there's the main production line that produces the product reliably, repeatably, but then there's the research and development side that just tinkers away on the design, and when they have it ready, then you move it over to the main production line. SpaceX doesn't have that. It's all meshed together in one, because ultimately at the core we are an R&D company. Every single rocket we launch, because it's not 100% the same, it's a research and development build, and that's the challenge that we currently have. That's the challenge that I have in my role as a manager of master scheduling. It's how to scale the line to go faster and faster and build rockets faster and faster when you don't know exactly what type of rocket you're going to be building next. That's not easy.
That seems like a really interesting thing that's being built in, which I guess is a pretty obvious comment to make. But when you compare that to companies like Lockheed and Boeing, who through the United Launch Alliance had a monopoly over that entire aerospace sector, essentially, you know, with rockets and that sort of thing, for many years until SpaceX came along and managed to break it. How do you think they will, I guess, move forward if they're the Ferrari and SpaceX Honda? How do you think that they will, I guess, will they continue to innovate, or will there always be a place for those highly well-built launch vehicles in space?
I think there will be a place for those reliably built. I think there will be a place, at least for the foreseeable future, in my mind. But they do have a challenge, because, as I mentioned earlier, the cultural mentality of new space companies being fundamentally different than old aerospace, I think that is the largest challenge. It's to try and compete with a company like SpaceX. United Launch Alliance needs to start thinking like a company like SpaceX. And to think like a younger company, you have to have younger people around. And the old aerospace companies, with their culture, don't attract, you know, the new the new mechanical engineer who has his eyes set on rocket science is first going to try and look at SpaceX or Rocket Lab or Blue Origin because they're the hot new thing, and I think that is a huge challenge for the old reliable aerospace companies, in my opinion. That's not to say it's unachievable, but I think for them to do that, they're going to have to do some pretty big soul searching, and it's they're going to have to make some hard calls.
So we've got a few questions lined up on Twitter. So if you're listening at home, hashtag MX17 is where we're taking our questions from. So the first question is, if rocket launches become negligibly cheap, how many rockets could be launched per day? And what would the limiting factors be, if not cost?
So to answer that question, I would say if production of the launch vehicle is essentially negligible, if we have a reliable launch vehicle that we can just churn out, 1, 2 rockets a day, the challenge then is the launch pad itself. We've never needed to launch rockets back to back in 24 hours on any launch pad at any time, anywhere in the world right now, or at least with big 2-stage liquid fueled rockets. Solid rocket, SDs, motors, model rockets. We do that all the time, but for the ones that go to space, the ones that put things in orbit, the ones that put the probes out into the solar system, you need those big launch pads, and that takes a massive amount of infrastructure, and currently still a lot of human interactions. There's a lot of things that people physically have to do at the launch pad right now, and to make all of space launch a negligible cost, and we're just going into space all the time, every day, multiple times a day, we're going to need to figure out how to automate a lot of that. The most powerful rockets in the world, besides SpaceX, besides the United Launch Alliance, we're talking China, Russia, India, they're all liquid fueled, and the liquid that's in most of those rockets is liquid oxygen, liquid hydrogen, or liquid RP1, and for the liquid oxygen, liquid hydrogen, that's obviously really, really cold stuff, and keeping a ground support infrastructure with hundreds of thousands of gallons of liquid oxygen and liquid hydrogen chilled all the time, ready for launch, that right now, that takes a lot of manpower and a lot of money. So it's not just about making rockets easier, it's also about being able to launch them easier.
And is that a problem that needs SpaceX? Or do you think that that's something that's to provide that? And the same thing for breaking up again. Oh, so breaking up? So just saying, can you?
Go ahead.
I'm sorry. Are we still clear?
I'm here.
Yeah, great, cool. So just saying, do you think that that's something that SpaceX themselves will try to address, to expand the scope of what they do to launch pads and maintenance and development of new ones that can withstand many, many launches? Or do you think that's something that could be pushed to a new supply chain, maybe new suppliers that don't exist yet could pick that up to start building more of that sort of space infrastructure ecosystem?
I think a little bit of both. SpaceX right now, we have to start thinking that way because we're reusing our boosters. So I mean, we're thinking in those terms, but you start to see countries around the world where the governments themselves are building their own launch pads to try and attract space companies, and some countries around the world are building have startup companies that are taking out leases on land and trying to build their own launch pads themselves to be a commercial enterprise, you know, building a commercial spaceport, if you will. So I definitely see the opportunity for entrepreneurs to like try and get in on this and to solve this problem.
So we've got another question here. If SpaceX dramatically scales up the number of launches we regularly do, does it have a plan for the space junk that will be produced?
I'm sorry, I missed the last part.
So if SpaceX dramatically scales up the number of launches and number of satellites that go into space, so an example is, you know, I think Elon's been talking about putting up another 1,500 satellites into a nice big cluster. Does it actually have a plan for dealing with the space junk, or for deorbiting these devices and just sort of clearing up orbit?
Well, if he has a plan for that, he hasn't told me. I'm not privy to much of the information at the company, but I would imagine that there's actually international regulations on space junk, and I don't remember the statute, and I'm probably misquoting a little bit, but I'm pretty confident somewhere between the range of 20 to 25 years. Like a satellite's life needs to either deorbit and burn up in the atmosphere in 20 to 25 years, or go have enough propellant left on board to boost it into a junk orbit, an internationally recognized junk orbit. So I would say that the 1,500 plus satellites that the SpaceX is trying to put up, and the thousands more satellites that other companies are trying to put up for other communications infrastructures. I would imagine that they're thinking about the end of life for these payloads and what to do about them. Plus, they're in my startup NewSpace Ventures. I've been introduced to a number of companies that are trying to solve this problem themselves for larger satellite manufacturers. There are companies that are getting off the ground that are specializing in deorbit capabilities. You know, they make thrusters or solar arrays that absorb the heat to change the satellite's trajectory just a tiny bit over the life of the satellite until it burns up, that sort of thing. There are these companies that are thinking about, you know, simple ways to solve this junk problem.
So I'm going to switch I guess the more regular around ITAR. So I just thought about it because you mentioned international companies working in space. And I was wondering if you could comment on how you think ITAR, those treaties might prevent collaborating with different national space startups and things like that. They're getting in the way in that being.
The last part of the question again was cut off. I know it's about ITAR.
So I was just saying, so ITAR, so that's the treaties that a lot of nations are signatories to. So for example, Australia is a signatory to one of the treaties where we have to be very careful with who we do who we do space activities with. And now that we're getting more and more commercial space companies around the world, do you foresee that there'll be any issues with space companies from one country having a really tough time purely because there's regulations in place, so they're not allowed to do work with other nations? And have you seen that happening already?
Have I seen countries preventing others from working with their companies in their borders because of international restrictions like ITAR?
That's right. Yeah.
I personally haven't seen that. I am aware of ITAR restrictions, but I strongly feel, just me personally, as this new space industry grows, as you know, the generations that grew up in the 80s, the 90s, the 2000s, as we continue growing and moving into positions of power in these governments around the world, the mentality is going to start changing, and the mentality of inclusion and collaboration is going to be much more prevalent. And even though countries may have treaties with agreements like ITAR, I think we're going to see more and more amendments to those, and special considerations being made as time goes on, because just like any new industry, there's going to be a lot of growing pains. I kind of, not completely, but I see a lot of similarities between the start of the new space industry and the start of the internet in the 90s and the early 2000s. People really didn't know what the internet was. Some people kind of thought it was a fad, but then there were these couple big companies that got in early, and policies and laws and regulations have been formed around this idea, because this industry is now here and in your face, and generating revenue for lots of these governments around the world, and they can't ignore it. And I think the same thing is going to apply to new space. These countries are going to start seeing they're going to start seeing their citizens interested and benefiting from the technological advances, and they don't want to get left behind.
You know, that's totally right. I think technology like CubeSats, I think, are particularly interesting, or just looking at satellites that you can essentially almost buy entirely off the shelf and design software for on top of that. I personally see that as almost being like a PC from back in the 70s. And I think soon we're going to start seeing commercial companies developing software, for example, operating systems on satellites you can buy off the shelf, and people running essentially or apps, satellites that you'll quickly be able to launch without having to have any knowledge of how the satellite actually works. I totally agree with that. So I'm going to start to move more towards, I guess, close to science fiction, but not entirely science fiction. So I've got a question here. Do you plan on going to Mars yourself?
I would lie if I said if given the opportunity, I would absolutely try. Yeah, if I was offered the opportunity to go to Mars, I would not pass that up.
Is that regardless of whether it was a permanent decision you'd have to make, that you couldn't come back to Earth, or would just be, look, I couldn't possibly give it up because it's so amazing?
So that's okay. Full disclosure, I was answering that if I would be able to return. If it was a one-way trip, that would be a completely different story. I would definitely have to talk to my wife about that.
Okay, what if she comes in?
I'm sorry, say it again.
Saying, what if she could go as well?
Then I would need to convince her.
That's fair enough. Question for myself: Would you ever go on a rocket yourself? If it was, maybe even a SpaceX rocket, let's say in 2 years' time, you get the opportunity to do a manned test mission or something like that, for whatever reason yourself. Would it be something that you would do, or would you be, too worried that something might happen? What would you say about that?
Yes, I would definitely give that opportunity a go. I couldn't think of if I was moving the needle a little bit for space flight, and especially if it was with the SpaceX rocket. I'm intimately familiar with who's building it and what's going on, and I would be pretty confident in it.
Fantastic. How much do you know about asteroid mining?
I know enough to have a high-level conversation.
Okay, all right. So what are your thoughts on asteroid mining? And do you think it's going to be as profitable as people think, or is it all just hype?
I absolutely think it's going to be as profitable as people think. Now, whether that's as profitable as soon as people hope, I think that's a different question. There's a couple. Every asteroid mining company that is out there right now, Planetary Resources, all of the startup and the investment money that Luxembourg is pouring into that sector of the industry, they're all doing the iterative step-by-step R&D. Some are taking the approach of, well, let's go to the moon and let's start mining the moon for resources. Others are saying, well, we can get much more bang for our buck if we go to an asteroid, capture it, and then bring it back into Earth's orbit. All of those are going to require, big jumps in our current technology, but it's not unfeasible. It's certainly possible to do. It's just in the time scales that we think we can do it, and in convincing the general public that it's actually possible. I feel that part of the reason why so many governments themselves haven't really done this is because governments are funded by tax dollars, and the tax dollars come from the citizens, and the citizens kind of think this is more or less a pipe dream, or that's something way down the line that they don't really need to worry about, which is kind of why it was so shocking that Luxembourg is saying, you know what, we're just going all in on this. It's fantastic that they're doing that. And I hope this yields some really promising results. But you look at some of the initial analysis at the types of asteroids that are near Earth. They're still pretty damn far away, but they're near Earth enough that we kind of understand what the composition is. And it's pretty exciting. We're going to need to figure out how to capture an asteroid. Let alone not just crash on one, but to be able to land and extrude resources successfully. Personally, I think a logical step would be, figure out how to do it well on the moon first and then go from there. But I do think this, if we want humanity to be a multiplanetary species, this is something we'll have to figure out sooner or later. And I'd rather do it sooner.
Yeah, I think it's a really interesting one, right? I feel like it's one of those things that just seems so far-fetched and so far away on the surface when you get to see asteroid mining. But I feel like it's going to be one of those things that all of a sudden is just here, in some way. We're not really going to realize that it's happened, but, may land on an asteroid. And it's going to, so creep up on us, and then all of a sudden we'll be in this amazing new world where we are just mining asteroids, and we have economies out there. We've got autonomous robots manufacturing things without really even noticing it. So it's very interesting.
Yeah, I think the first company that can legitimately say that they've gone to an asteroid, mined something, and then brought it back, that's going to be a big deal. And even though the cost on the return on that investment has a long time to even pay out for something like that, that is still in and of itself going to be a huge achievement.
So we might start to wrap it up, but I want to ask you one last question. So you were in, say, Elon Musk's position a time ago. You had, let's say, $100 million, and you wanted to start your own space venture. What would you do right now?
Right now, if I had that amount of cash laying around and I saw the new space industry, I would actually either invest or start myself ground stations, ground support infrastructure. One of the things that I've noticed is that there are a lot of companies that are saying, hey, we want to put up these satellites up into space, or we want to launch these rockets. And that's great, but to stay in communication with those rockets, you got to be able to talk to the ground. or at least have the infrastructure either on the ground or in orbit to be able to communicate with those things. And I haven't seen nearly as many companies trying to fill that gap yet.
Right. Well, thank you very much, John. It's been fantastic having a chat to you. We really appreciate the time that you've taken on your Saturday night. So thank you very much for joining us here at Space Apps in Melbourne, and hopefully we've had a few viewers from around the world as well. But great to have a chat. Is there any last words that you'd like to say, maybe to inspire some of the Space Apps challenge?
Well, I would say sign up for the NewSpace Ventures newsletter. It's 2 months old, like in a week. We're really new, but we have you'll be able to see some really interesting startups and companies and products and services from around the world in your inbox every day. We've gotten some great feedback and support from entrepreneurs, students, founders from around the globe saying like this. It's really inspiring to see these companies around the world doing things, and it's inspiring them with ideas as well. So please do that. Also, SpaceX is launching in a couple days, where we have our NROL launch from Cape Canaveral. So go ahead and tune into that if you have the opportunity. And if anybody out there who's watching this has any questions, they can certainly reach out to me, and Troy, you can give them my contact info.
Thank you very much, John. It's fantastic to have you.
Thank you. Thank you. Yeah, great.